Hello. Yeah, I'm going to start a new series on multimedia processing. And here I'm going to give you some, very briefly, some details of, or an overview of what is multimedia processing about. Now, multimedia processing is applied a number of places. Like, for example, even your cell phones, your computers, right? Number of places where you want to predict something based on the media, like based on like voice, or let's say image data. So all that comes under multimedia processing. So I'm going to start with an overview of what is going to be there in multimedia processing. So first we are going to talk about uh, audio sorry image processing. That's very famous these days, and it's applied in a number of places. Then we are going to talk about audio processing. Hang on a second. And then we are going to talk about video processing. Right. So I'm going to start with image processing, or what is called digital image processing. Okay. Uh, Without going into applications of this image processing, because applications of image processing are vast, and I would be doing something and then approaching those applications than just having a hollow lecture on what image processing could do, right? So here I am going to talk about image, right? So an image is a two-dimensional signal. So it's a two okay, the two dimensions being x and y, or you can say rows and columns, right? So you can say x and y, or rather I can say y and x. So this side I can treat as y, the convention as we are used to, and this is x. So any point would be x comma, well, let's put it back, x comma y. Okay, so let's say this is x, this is y. So rows, I mean by rows is x, and columns are y. So any point would be x comma y, right? And the origin is over here, 0 comma 0, 0 row, 0 column, and any point in this is going to be x and y, and this would be the height, and this would be the width, right? So an image is going to be a two-dimensional signal. So the two dimensions being x and y, it can be considered as a two-dimensional array. Now, is array a good way of storing images? Answer is it's very inefficient. It stores over a stack. It takes your valuable stack, so you can store other places, right? So when you process large images, you are going to run into problem if you do something like storing it arrays. So we will talk about scalability later on, right? But to start with, an image is just a two-dimensional array. It's numbers, right? And what these numbers are going to be, what is their range? So that number is of data type uint. Okay. Now this uint is also a unsigned character. So we know that the information in a uint is stored in 1 byte, and being unsigned, its range is from 0 to 255. So any pixel x may have an intensity which is in this range because it is represented by 1 byte, right? So I can have X rows and Y columns of 1 byte each. So this unit, okay, is called a picture unit or a pixel. Okay, so pixel is basically 1 unit on that image. Okay, and this is also known as raster image because there is no compression, there is no information on, there is no, it's rather just a bitmap, right? So the very basic, okay, format would be an uncompressed bitmap. Okay, so bitmap is uncompressed. So I can, there may be compressions. So there are some formats of bitmap which may be compressed, and the simplest compression is a run length encoding, which we'll talk later. So bitmap basically is a raster image or a two-dimensional array. Okay, it is uncompressed. Okay, so it is uncompressed. So 1 byte is going to be between 0 and 255. So this image, which is going to use 1 byte per pixel, okay, it can store a black and white image or a color image, and I'll tell you later why, how a 8-bit image can be a, so 1 byte basically means 8-bit, 8-bit or a 1 byte image. So I'll tell you later how a colored image can be stored as a 8-bit image, right? For now, let's say by default I'm considering that this is going to be a grayscale image. So basically between what you call black and white, okay, there are going to be 255 quantization levels. This means that 255 is white and 0 is black. So this is the entire range. Okay, so this would be called a grayscale image. So this would be called a gray is what? Sometimes I get confused. Okay, okay, so this will be called a grayscale image. Okay, so now having said that, how about making it colored, right? So if it is a colored image, instead of using 1 byte, I can use 1 byte per color, per primary color. So we know that the color can be made from 3 primary colors. So these colors are RGB. So for all your display purposes, okay, we have got so 1 byte per RGB. So this is going to be 3 bytes per pixel. Correct? And so that is going to be equivalent to 24-bit image. Now some images can also use 4 bytes. 4 bytes per pixel. Okay, and what it does is with 4 bytes you have got an additional byte which is used for alpha or transparency. Correct? So we have got a black and white image, and this would be a colored image. Now we can also have a 1 byte image for color. So our 8-bit BMP is possible. I'll tell you how. 1 byte colored image. Now in this case what's going to happen is I can support 255 colors. Okay, now here in this case of 24-bit I can have 16 million color shades. okay, because it is 2 raised to 24. So we have 16 million color shade. Here I'm going to have only 255 colors, and these 255 colors are in a color map. And what's a color map? There is kind of a code book. For these 255 colors, I'm going to give a byte of code, which is stored in the color map. So whenever I refer to a value, I will refer to that in a color map and see what color is going to be, right? So color map would store, you know, the colors, right? So that's how a 8-bit or 1 byte image is possible. Now for our purposes, I'm going to start with a very simple grayscale image, or a colored image, which is going to be 24-bit, right? Now we have already seen, or we can see it over here again, what that what that, sorry, header for the BMP is like. Okay, so we can go to C and open that image and see the colors. Okay, so this information, if you are using a MATLAB, you might this MATLAB might be doing in the background all the image acquisition part, and you may be totally unaware of what that is, right? So here I can write a simple code to open a 24-bit image, right? So here let's go ahead and make a new project. Okay, while this opens this, let's go ahead and do a fast way of doing things. Okay, so here I can basically write a function or a script file in MATLAB, right? That script file is just one unit, right, which can be run by calling its name, right? So let's write a script file. Okay, I'm going to save this first. Okay, and I will say play imgs. Okay, so play imgs is the file which I have created. Now here, as usual, I would say close any figures which are there by default, close all, clear all, clear any variables in the workspace, and CLC. Correct? So if I was to run this, it's going to just clear this. Okay, it might come with the warning, it's unnecessary and all that stuff, but that's okay. Okay, so here I can go and acquire an image. So first of all, you can type the path to the image in your code, but that's very tedious if you work with number of images. So what I'm going to do is I'm going to read the image from a dialog box. So I can say file name, comma, file path. Okay, and I'm not sure if the order is correct, but we'll correct it later on. And then you say UI get file, and so this UI get file is going to launch a dialog box, and it's going to return file name and file path, whichever you select. So if I run this, so this opens, and then I can go to the folder which is on the desktop, DSP images, type as all files, and let's say I want to open this image. Okay, so it gives me over here in workspace, you can see it has given me the path and the file name, correct? So this is how I'm going to read the path and the file name, and then I can say full name is going to be equal to, and I think plus works in MATLAB, so I can say file path plus, I'm not sure if this works, but otherwise there will be string concatenation, somehow I have to do that, right? File path plus file name. Okay, so let's see if this works. Run. So I'm going to go back to the image, all files, Audrey. Okay, matrix dimensions must agree. So yeah, so this is treated as a matrix. So I have to do str concatenation, right? Help str cat. Is there a function like this? I'm not sure, but that's the beauty of MATLAB. You learn as you go. Yes, there is. So I can use strcat, right? So I will use here. So of course this treats even a string as a matrix, right? So it will try to add the element by element. So that's what it's trying to do, which is not what we are trying to do. So how about that? So now if I run this and I go to the image, sorry, and choose this image. So you now see that there is a file path, and then there is a, so let me see if I'm recording it. Yeah, so there is a file path, there is a file name, and then I combine both of them, and that's my file. Okay, so now I have to read this file. So I have got the path, so I have to read the file. So how do I go about reading the file? Okay, so then I can read the file to a matrix. So I can say A. Now there is the inefficiency which would come in. Okay, so when I say A is equal to, and I say I am read, and over here I am going to pass the path, which is full name. Now here I'm starting with MATLAB, zero information on MATLAB. I am not a MATLAB programmer, for example. So I'm learning on the way I go. Okay, so it says A equal to I am read, full name. So let's see if it does that. So it opens the dialog box. I choose the image, and voila, you have got A, which is 512 cross 512 cross 3. Okay, so now that's the image. Now here's few more things which I'll do before I go into processing this, right? So let's say I am going to do okay, so I want to look if there is a function called IAMinfo. So I'll say help IAMinfo. There has to be. Okay, so IAMinfo is not found. So maybe this is not the function. So for that, the best thing to go is to go to Google and say I want to say IAMinfo in MATLAB. It will come up with some information. Okay. IMF info. So that's the correct instruction. So IMF info, file name, format. I think format is also optional here. Okay, so format is also optional. Okay, so I can just say IMF info file name and it will return as a pointer to a structure, and that structure will have all the information, right? So this is the information which I'm looking for. Okay, so let's keep this to side, and here I'm gonna say info is equal to. Now the fun part with MATLAB is you do not have to specify what is A. It automatically detects that A is U int 8, right? And then also it doesn't, you don't have to tell what is in IM info, what is info, right? So I can say IMF info, and here I'm going to say full name. Okay, so now if I run it and go to the files and look for the same file, oh, typing mistake, info, sorry about that. Okay, so let's run this again. So that's the fun part with MATLAB. You don't need to know all the functions, and you'll discover on the way. So it has a structure, and what's inside this structure? I don't know. So it says it's a structure with 24 fields. Okay, so it's trying to explain what is a structure, but then this is the information. Okay, so the information is file name is this, okay, modified date is this, and modified time is this. File size is 786486. Now the height and width is 512, and bit depth is 24. So 24 means there are 3 bytes per pixel, right? So there's going to be 512 into 512 into 3. So that much will be the size of the data. 512 multiplied by 512 multiplied by 3, plus there is a header which is going to be 54 bytes. So 786486 is the size of the image, right? What else it says? It's a BMP, it's a version 3, height and width is 512, depth is 3 bytes per pixel, true color, okay, format signature BM, okay, then color map null, okay, so this is not a 8-bit image, okay, so there are no masks. Okay, here says image data offset, that's 54. Okay, so if you refer to my C programming, I opened the image using C and I showed you that. I can show you here also again what that is. Compression type is none. So where is it getting all this? So this is horizontal resolution. So how many pixels per meter? So that's the information, is how many pixels per meter. So this has to do with the camera information. You know, what is the camera resolution, and then how many pixels, number of colors used, number of important colors. Now this all information which MATLAB is getting, it's not getting from anything special. Okay, so I just wanted to show you it's nothing special in here. So I can create an empty project, call this project as, okay, disco image. Okay, discover image. So see, what happens is MATLAB is not doing any magic, right? That's all what I'm trying to say. And why I need to show you this is because, you know, these days OpenCV, MATLAB, they all have been shown to be doing some magic, which it doesn't, right? It's very simple processing. So I'm going to add a file here, add a new item, and I'm going to say read img. So this is my own function, read img dot c. Okay, add. Okay, so first of all I'm going to do hash include, hash include, then I'm going to say std io.h. Okay, and maybe if I use something like size of and all that, std lib.h hash include std lib.h. Okay, so now I am going to read. So I don't have that fancy dialog box, but later I will develop the code for that fancy dialog box also, which you get it from UI get file. It's nothing but it is calling Windows Win32 API. Standard dialog box is it's open, it's calling, and it's retrieving the path. So it is not doing anything special in here. Inside the hood, it is just calling a API, Win32 API call. That's all it's what's trying to do. So here I am going to have int main void, and I'm going to write the code here. So first and foremost, I'm going to have a file pointer. So a file pointer. So this is a pointer to a file fp, right? And then I'm going to do a f open. Okay, so fp is equal to f open. Okay, and here I'm going to put a string. Okay, so here the string is going to be the complete path of the file. So here the path of this file is going to be here. So this copy and this paste. Okay, now you should know a little bit about fopen, but let's just do this and later come to that. Okay, and the name of the file. Okay, sorry about that. The name of the file is Audrey. So I'm going to paste here. Okay, so you see a lot of stuff, right? This OpenCV and this and all that. These are nothing but a bunch of algorithms, and this bunch of algorithms have been just collected under what is known as OpenCV. You can even get a access to OpenCV from C++. You did not do a MATLAB. Okay, and then I have to tell what mode am I going to open. So I'm going to be opening as a read binary. Right, so if this file open is a success, okay, so now if you are in a confusion, okay, so if f open is a null, okay, then I will say file failed to open. If fp is equal to null, so it's a null pointer, then just write a message printf, okay, and then just put the text here, fail to open the file. And then I would just do here exit 1. Okay, so if it fails to open a file, it will just write a message and exit. Okay, else it has opened the file. I'm going to do something here. Okay, so I am going to read. Okay, so I'm going to read what's there in that file. Okay, so first of all, you should know what structure is there in the file. So I will go to again to Google and say Bitmap header. Okay, if I go to Bitmap header, I can open any this stuff. Okay, so it just says it's not clear here. Where is it going to be clear? Okay, so it says file signature is 2 bytes. Okay, file size is 4 bytes. Reserved is 2 bytes, and reserved is 2 bytes. And then pixel data offset is 4 bytes. So this is a structure which I need to create. So what I'll do is, first of all, I'll get the things out of the way of the first 2 bytes. Okay, so I'm going to say unsigned character, unsigned character ch. That's what we are trying to read. And here I am going to say if every time, f read. Okay, and here I'm going to read, or rather, I'll just not put that checking. So I'll just say f read. So this is in binary mode, and here I'm going to give in the pointer to the character where I'm going to read it. And here I'm going to say size of character. That's the size of the character. And then here I'm going to say how many characters do I want to read, and then here I'm going to say from which file am I going to read. Okay, so this is reading the first character, and then I'm going to display the first character. So I'm going to say here printf. Okay, printf say okay file signature. Okay, then I'm going to say percentage %c. Where is percentage %c? Percentage %c, right? File signature percentage %c, comma ch. Okay, so I'm going to run this and see if it reads B. Build error, F open. What does it say? Okay, CTS secure warning. Okay, so this is kind of deprecation related issue. So I have to define here hash define this variable, which is underscore CST underscore secure no warnings, SECRE no. Okay, so what did I do here? No warnings. Okay, so we have created the same variable here, CRT secure no warnings. Okay, have done that. We'll say start with the debugging. Okay, signature file signature B. Correct. I'll read another character and put it over there. Control C, Control V, and here I am reading this again, and then I would say printf. So Control C, Control V, and here I'm going to say %C, and that's CH. So it will now read BM. Okay, so it says BM. So file signature is BM. And what did the MATLAB do? If I look at the structure, it says file signature is, or format signature is BM. Correct? So what about the other headers? I can just type a structure. Okay, so very quickly, let's go back to here and create a structure. Okay, and a structure, I'll say img info, and this structure is going to have, okay, so I'm going to just type here, what do I expect? Okay, let's see. Okay, I expect so the file pointer has moved to here now. I expect an integer, a short, and an integer. Okay, so the first integer is going to represent the file size. Okay, so okay, so I'll say unsigned int f sz, or file size. unsig. Okay, then I'm expecting a unsigned short. Unsigned short, and that unsigned short is going to give me file size. File size, after file size, what do I have? I have a reserved, and it will come out as 0. Reserved, and so there's something wrong here, is it? There are no two reserved, so there's something wrong with this header information. Why there are two reserved? Signature file size 4 bytes is reserved, so I'll read that as also integer. So go here. Okay, integer, that is RESV, so that is mostly going to be 0. Then unsigned, okay, and again it is going to be int, and I would say is img offset, correct? So that's there, and I am going to create a structure img inf, and here I can say fread pointer to img inf, comma, size of img. I can also put here this one, structure, right? So rather I would say img inf, size of that, comma, then I can say one header, okay, and then I'm going to say from this file string. Okay, so now I have read the image info, and now I'm going to display that. Okay, so over here I should put a new line character. Okay, so I can say printf Control C, Control V. Okay, so here I'm going to say printf. First thing it's going to put in here the file size. And then here I'm going to put %d, and here I'm going to put here that structure imginf dot fsz. fsz, correct? Okay, so that will be that. Then I'm going to read the reserve word. So I'm going to put here reserved %d and here again new line character, and here I'm going to put imginf dot, and that's resv, okay, comma, and again over here I'm going to say data offset. Now if this data's offset is 54, that means there is a image info of 14 bytes followed by a header which is 40 bytes. So that is 54 bytes, and then the image data directly starts from there. If not, okay, then there would be image data starting at the 54 plus the color map size, right? So data offset %d, and here I have to put imginf dot image offset, correct? So let's see what it does. So if I run this, okay, so file size is 786486. Let's go to MATLAB. That's doing the same stuff, right? Then it's saying reserved is 0, data offset is 54. So let's go to MATLAB. It says, where it says offset, so image data offset is 54, and then bitmap header size is 40 because it doesn't have a color map, right? So this information would come in the other structure, and the other structure is going to be let me just show you. The other structure says, okay, header size, so that header size would be 40. Okay, image width 512, image height 512, number of planes 0 or 1. Okay, so it means it says 1 or 2. So how many planes are going to be here? So that's going to be short. Bits per pixel is another short, which is going to be 24 bits. So that information is over here in MATLAB as true color or whatever, right? And 24. So that's bit depth 24. Then it will also tell you whether there is a compression or not. So if you go to here, it says compression 4 bytes. If it is 0, there is no compression. Otherwise, 1 means it's going to be 8-bit image. 2 means it's going to be run length encoding and all that stuff, right? So this compression will give you compression code. And MATLAB basically just reads that. So color map is empty, all this empty, and number of planes is that, compression type is none. So that's what it is reading. Okay, and then you will see that it has x pixel per meter, y pixel per meter. So that is your scaling. So in MATLAB that shows up as horizontal resolution, vertical resolution, that is 4724, right? So that many pixels per meter. So that's what that is. Okay, so then the last one is total number of colors and important colors. So you go to MATLAB, it says total number of colors. color type, no, total colors. Number of colors used 0, number of important colors 0. 0 means all colors, 60 million shades are important. Okay, if there is a color map, then it will tell you, how many colors are being used in the image. If it is not a 8-bit image, you will not get that information. So you now see that MATLAB is not doing anything, fantastic under the hood when you do a IM read. Okay, so it's just that. Okay, so having said that, let's look at the data. So all you have to do is move the file pointer to the 54 address, 54, and from the start, and then from there you will start reading the RGB per pixel. Okay, so that's what it is doing. So here MATLAB is doing the same stuff. Now, but the problem here is the following. Okay, MATLAB doesn't give you a control over how it's going to store the data. Okay, while C, you will be under the you will take your control. You say, I want to store it over the heap, not the stack. So in MATLAB, if you are going to create a large matrix, it's still going to the stack. So then the physical RAM becomes important. Okay, so that paging of the file doesn't take place. If you are using malloc and allocate the memory on the heap, then the OS would be handling the buffering, right? Or you can change the size of the buffer too, right? So here, whether MATLAB is going to scale to Landsat images or not, I'm not sure, because it will just come up and complain that there is a segmentation fault and I can't read the image, it's too large, right? So this is for good for the beginners to write a quick code, but for production grade software, I would write it in C, right? Not even .NET, C#, because again there is a limited control with the pointers in .NET, okay, or Java. So because that's all managed code, that means that there is a garbage collector there, and I have no control over garbage collector. They think that they have done the most optimized stuff, and then they say there are no memory leaks. But as a developer, I need control over my resources, and I need to handle what I want to do. So that C or C++ will give me the control, and it's going to be much faster than MATLAB or Java or C#, because MATLAB, Java, C#, they are compilers. They are not compilers, they are interpreters. So basically these are hybrid languages, you can say. Okay, so they are going to be slower. Second thing is that in C, C++, these data types are primitive, right? They require lower space to store. While if you do this in C# or Java, in Java they are still native, so they are going to take less space, they are going to be faster. But in C# they are going to be objects, because even the primitive data types are objects in C#, right? So that's, if you do image processing using MATLAB, what happens, if you use C#, what happens, if you use Java, what happens, and if you use C and C++, what happens, you have an idea, right? So as a developer, you don't have that privilege to have of a large memory, right? So if you remember, okay, we send the Americans send the space mission to moon, Apollo, and how much memory did it have? A few megabytes, right? And if you pose this question to today's engineer and say, if you do this in few megabytes, they will just raise up their hands, right? Now I remember when I was doing image processing, we were doing vector processing, and we were using this allocation and the files and stuff like that to read Landsat images, right? Which are in like gigabytes. If you open a gigabyte image in MATLAB, it's just going to fall apart, right? So it's good for the initial stages of learning, but it's not good for production grade. Okay, so now what am I going to do? So A has got this information. Now what I'm going to do is I am going to display the image. So I can say I am show. Okay, and I hope this is correct, and I haven't done with anything with the characters or unsigned character. So I guess if I run this, it's going to show the image. So it's taking a lot of time, you see. Is it going to show me the image? When is it going to show me the image? Oh, it did. Okay, so it has shown me the image here. Right. Now I want to split this image into 3 colors. Right. Now you see they are stored in 512 cross 512 cross 3. Okay, so these 3 levels are going to be 1, 2, 3. 1 for red, 2 for green, and 3 for blue, RGB. Okay, so if I want, I can split that into RGB. So all I have to do is I can make B as A. Okay, so I can make B, sorry, B, or I can say R, or red. Okay, so red is equal to 512 plus 512, but I don't want to use a number here, so red is equal to A. And then I can say red of, let's say, how do you do indexing here? You do it in these brackets, right? And say everything, comma, everything. So this is XY, comma, 1. So if I'm right, that's how you index it, is equal to 0. So it will fill this with 0. So let's run this. So if I have typed it wrong, it will just complain about it again. Okay, it didn't complain about it, right? So red size is also this. Okay, so now here, do I need to cast it? Maybe I cast it and call it as uint8. Does the casting go like that? Or does the casting go the other way? Convert this to uint8. Does it go like that? Okay. It was a uint8 anyways. So it will do its own. I don't have to cast it. Unless I do, if I do some mathematics on it, then it will become a double or something else. So this is the first one. So instead of first one, I'm going to make the second and the third ones are 0. So I can say second to third 0. How's that? So let's run this. Okay, all files, images. Okay, so I'm expecting that second and third are filled with zeros. So how do I verify that? I can very easily say that I want to say red everything comma 2. So this is all filled with zeros, right? Then I can also say look at plane number 1, and this has the image, right? And then I can say plane number 3. So that's also 0. So I have separated the red image, and I have how have I separated? I just made 0 everything other than the red plane. Then I can say green plane, right? Green is equal to, then I can say here A, and also I can say blue is equal to A. Is this the most efficient code? I don't know. So here, Control C. So in case of green, I would have some issue. So I would say, because it's not continuous, right? So I would say green 1 and Control C, and here I would say green 3. Okay, so 1 and 3 are 0 here. Then I can say blue. So I can just type here Control C, Control V. Right. Okay. Okay, so here this is blue. Okay, so blue 1 comma 2, 1:2. So the 2 indices. Press delete button. Okay, so that's that. Okay, so now I have separated red, blue, and green, and I can put it in 3 different figures. So I will say figure 1 is the original image. Okay, and I can put here title. So I don't know if it is a small title. Okay, with MATLAB, if you have an error, you just fix it. So I think strings go like a single character in this, isn't it? And say original image. Okay, so here I am going to just run this, go to that image. If there is any syntax error, I'll get it. So it didn't put the title here for some reasons. Okay, so it means that I'll have to run this code again. It goes like a string then, like this. Run image, all files. How come I couldn't put the title here? Okay. Okay, I'll try to find out what happened with my title, because I don't know MATLAB. I'm learning along with you. Okay, it did. So the reason being, it has to be after I am show, which I expected. Okay, so then I can put here 3 of this. Okay, Control V. So this is going to be figure 2. Then I'll later talk about subplots. So just put here this and say this is a red image. Okay, and then I would put that again, figure 3, and that is going to be the green image. This is going to be, so sorry, here it is going to be red, and here it's going to be green, and then one more time I have to paste it. That is figure number 4. That's going to be a blue image, blue, and say this is green image, and this is blue image. Okay, So now I'm just going to run it and see what it does. Okay, let's see. Okay, so that's your red. That's your original image, sorry. That's your original image. That's your red component of that image. That's your green component of the image. And that's your blue component of the image. Okay, original, red, green, and blue. Okay, so now that we have read this image and I have separated the three planes, then I can do a separate statistics on these three planes. I can do, so the first step is going to do a lot of uh, photometric manipulation rather than geometric manipulation. So what I mean by photometric is that each pixel manipulation is independent of the neighbor. Okay, so each pixel manipulation is going to be independent of the neighbor. That kind of processing I can do. So in that case, what you can do bit plane slicing, you can do gamma correction or whatever, right? Power law correction or whatever, right? You can convert this image into a grayscale image by combining this red, green, and blue in certain way which your eyes accept. So that will be your conversion. So there would be a separate function here which says I am to gray, which would be nothing but, so if you go to Google and say okay, color to gray formula, color to gray formula. So it is not just the average of the 3 pixels. It says the formula is 100% correct. No, this is what our eyes accept, what proportion, how much sensitive is it to the red, how much sensitive it is to the green, and how much sensitive it is to the blue. Okay, so there's a weighted sum here. Okay, and the sum of these values is going to be 1, right? So 0.21 plus 0.72 plus 0.07. So how much our eyes are sensitive to which color, and accordingly we will convert it to the grayscale image. Okay, you can of course do this, but then your grayscale will not come out to what your eyes are accepting, right? So that's there, which we'll do later. Okay, then you can do some statistics on the image. You can find out the mean, median, mode. Then you can also find out the standard deviation. You can also find out you can do contrast stretching, right? You can do a power law or a gamma correction. So these are all single pixel, right? So you can do that. So that will be the next lecture or next session, right? So to summarize, we just learned something about what's an image, right? And that's what we have done. Okay, so in next session, let's see you with doing photometric corrections here. Thanks a lot. Thank you.